Good morning, one and all. Today, we're going to be looking at internal combustion engines. I'm Lieutenant Commander Jeet Jacob. I'm a student at the Department for Computational and Data Sciences. This class is going to be pitched at a very introductory level so that those of you who are not familiar with the topic can understand on a very superficial level as to what are the important terms and what's the design and what's the structure. So without further ado, let's move into the topic. Today, we'll look at what exactly is a heat engine. We'll look at advantages, we'll look at types, and then we'll look at what are the parts of an engine. And then, the classifications, as I said, types, and then you compare them so that you get a perspective as to what this piece of equipment is and how do you appreciate the variants of this equipment that are available in the market today. To start with, a heat engine is a device which transforms the chemical energy of the fuel into thermal energy and uses this energy to produce mechanical work. There are two types, internal combustion engine and external combustion engine. Now, in the case of internal combustion engine, the combustion takes place inside the cylinder. An example could be any diesel engine that you could see on the roads today. An external combustion engine is somewhere where the combustion of the fuel is happening somewhere else outside the engine. An example would be steam turbines. Just to compare, just to understand what are the differences, we look at why internal combustion engines are better than external combustion engines in certain regards. You can see that they have a higher power to weight ratio. They have a lower initial cost. They're compact. Think about the engines in our cars. They are lower maintenance and easy to start and very well suited for starting it remotely also. However, the external combustion engines also have plenty of benefits when you compare it with the internal combustion engine. We know that our steam turbines use cheaper fuels and they give us a better starting torque. That is why we see them used in, sea-going vessels, huge ships. Think of Titanic. And we'll now come to various parts of an engine. Now, please keep in mind that this is not binding. Different engines could have different variations, but you could look at it as some kind of a standard, some kind of a benchmark as to every engine has got to have these parts in some form or the other. The major part is cylinder block. So you should visualize a block in which a liner, which is called a cylinder liner, is placed. And when two or more cylinder liners are held together, it's called a cylinder block. The head of the cylinder is generally made of cast iron and is held down to the engine by bolts and nuts. These are listed on your slide are the various parts of a cylinder head. We'll try and go through it in detail in diagrams that are coming up in the presentation. We spoke about cylinder liners. Cylinder liners, as the term explains, they are liners within the cylinder. They're inserted into the cylinder block, and within this, the working of the piston happens. The piston moves up and down within the cylinder liner. These liners could be dry or wet. Flywheel. Flywheel is a large and heavy wheel fitted on the drive end of the crankshaft. It stores parts of the energy produced at the crankshaft in the form of momentum. And a camshaft is different from the crankshaft. This is driven by the crankshaft and it's an accurately machined cam profile, shaped according to the rate at which the valves are to be opened. There is also the rocker arm. Now, this diagram will help you, understand the parts that we are speaking about right now. You can see that this is the overhead assembly. Visualize this over the cylinder. You can see the camshaft and rocker arm and stuff like that, which we just spoke about. The piston, you've seen animations of the engine. Piston is one of the most basic components of the engine. The piston reciprocates rapidly in a typical reciprocating engine. And this is what a piston's cross section would look like. There are rings across the surface of the. There are very many valves within the engine. There are inlet valves, there are exhaust valves, etc. And then there are spark plugs to initiate combustion. Typically, a valve would look like this. More parts. We have injectors, we have fuel injection pumps, and then we have carburetors. Now, bef- now we move on to how we classify these engines. You could have compression ignition, which is what is done in diesel engines. You could have spark ignition, which is what in petrol engines. We could have two-stroke engines like old motorcycles. Four-stroke, most vehicles now have four-stroke. The cylinders could be arranged in a line, they could be arranged in V in a radial fashion. You could have battery started engines. Again, think of our cars. We could have air started like in ships and manual started like generators. You've seen people pull that, tug that starting cord. You could have air cooled, water cooled. You could use one fuel. You could use a mixture of fuel. Very many classifications. Now, in this slide, you can take a look and you can see that cylinders could be arranged in all these variations. Uh, we also know about four-stroke and two-stroke engines. Primarily, the difference is that the cycle is completed in two strokes in a two-stroke engine and in four strokes in a four-stroke engine. You can see the differences on the slide. We have spark ignition and compression ignitions. Spark ignition is your petrol engine where you have a spark plug. Compression ignition is your diesel engines where the mixture catches fire by virtue of the high pressure. If you have any questions, please don't hesitate to leave them in the comment section. And thank you for your patient hearing.